Hello there.
Well,
How are you?
doing good.
Doing good.
Yeah.
Sounds like sounds like the third month of the semester.
Yeah.
You know, work is piling up. You barely have any time to sleep, and you have to get up early in the morning, and you become guilty if you didn't.
So I found all my pay stubs. I'm trying to figure out how to get the scanner connected to my computer right now.
You can take a photo. That's fine.
I can take a photo. Thank you.
Yeah, yeah. As long as we can read. We
Uh-huh.
can read whatever is on it.
All right. Thank you for that.
Yeah.
Hi, Dr. Ma. Quick question.
Yeah.
It's about the capstone projects. So can I take both of them in one semester, or I have to take them into different semesters?
The answer is no. You have to take it in 2 consecutive semesters.
Okay.
Yeah.
Okay.
Mhm.
So, like, any more information about that? So does like will next semester's project still in healthcare industry?
Very likely, very likely to be the same company. Um, we are,
Uh,
yeah.
oh, and for the 2 consecutive semesters is like, do we follow the same project for 2 semesters,
Uh,
or
I think the best
it,
best scenario will be the same company and continue with the progress. I don't think a semester is enough to do a thorough job, or a semester is not enough to come up with a solution that is sufficient. So the second semester, hopefully on the same team, same company, you can improve the solution or complete the solution. One course doesn't have to finish the whole project just because of different situations. What we I mean, the way we evaluate it is given the resources, how much you can do and how much you did. How well did you do? So that's the way we evaluate.
okay.
Make sense?
Yes, thank you.
Great. So just a quick question, Seben, you have by the end of this semester, you would have taken all the courses, the required courses.
No, I haven't took the capstone project, and I didn't
Other
take
than the capstone,
the BZAN quantitative class.
you haven't
Like,
taken the. Did you have you taken 6310?
no, no, it's like the like quantitative for
So that's
business and
52.
yeah, 52.
But have you taken another course which is 6310?
Yes, I did.
Yeah, you took that. You don't have to take 52.
Okay.
Yeah, you couldn't have taken this class even or the advanced programming if you hadn't taken the 6310. So 6310 is a temporary substitute for that course. So considering that, you have by the end of this semester, you would have completed all 7 required courses.
Yes, I think I did.
Great. Yeah. So you're in good shape to enroll in the capstone project next semester. And this is what I say to everybody who have questions about capstone project. The second part of the capstone project, even if you have to do it in the last semester, even if you don't have any other courses, so if you're only taking that second class in one semester, that's fine, and you don't have to be in Houston. You can be anywhere, as long as hopefully in the.
See you guys in January.
Hopefully in the West Coast. I think we have a guest. Who is that? Right. So you can be away. You can work remotely. But if you work in town, that's even better, right?
The thing with taking the capstone project, the last semester, the last credit in your last semester, you don't have any other classes, is you're still paying full tuition for just one class, you know? It's not really a lot of value.
Tuition is by credit, right?
I think you have to pay the fees and everything too.
The fees,
Like,
maybe we can work something out. Right. If that's the fee, if only the fees is what you're concerned about, we may be able to work something out. If it's a visa related, then we have to
you can't work that out.
think more, right?
Yeah.
Fees are not a big issue.
Oh, okay.
Right.
That makes it better. Thank you.
Yeah. We can argue that, I don't know. Anyway, we can work things out. How much is the fee?
I don't know, but I know it's more. It would be more than tuition. Not more than the tuition, but it would add on to the tuition. You know,
Yeah,
like
yeah.
paying for just a single class. I'm not sure how much it is.
Yeah, the
Okay.
fees would be about the same as, well, so 1 hour is like $830 something, and I think the fees are at least like $500 to $600 per semester. So if a 3-hour class, you're looking at $816, $2,400 plus $500, $600 in fees. So you're still looking at like $3,000 for the semester for one class.
Is the fee proportional to the number of credits you enroll in?
No, not as well. There might be parts of it, but most of it, no.
Okay, so it's a flat rate.
Yeah.
Okay. Yeah. Yeah.
And then they tried to adjust it for like this semester distance learning. They tried to decrease the fees for like being at school, like the rec center and whatnot, but then they just increased the online fees, so we're still paying the same thing.
Oh, poor you.
Yeah.
Yeah. Okay. Hope if this continues, if the situation continues, I hope it will improve for you guys. But most of you are almost completing, right?
Yeah.
Yeah. So that's a good thing. So anyway,
Yeah,
let's.
virtual graduation in December.
Yeah. That's
Yeah.
fine. Well, all right, let's get back. Welcome back. I said something about summer is gone, winter is coming, and now we're back in summer again. I guess that's Houston.
That's the thing with Texas, is you always have that fake fall.
Steak fall.
Fake, as in like faux, fake, just a tease.
Fake, yeah, fake fall.
Yes.
Yeah.
And then it gets hot again, and then all of a sudden we get 2 days of cold.
Right. Yeah, the cold waves and hot waves, it's back and forth. It's never really winter. But, I've been in Wisconsin, in upstate New York. Besides those heavy, blizzards, basically, it will last 3 days. Then when the sun comes out, the snow melted a little bit. It still feels like spring, despite the snow on the ground. So, on most days, the weather is mild. And in Texas, it's almost like summer. Anyway, so let's get started. I think today is, I don't know if, I said I will talk about collecting data from Yelp and from the internet in general. I don't know if you'll like to hear something like this. This is firsthand experience and multi-years of experiences dealing with multiple websites. I'm using Yelp as an example because it's so far the most sophisticated website I had to deal with. And so, there was challenge, and then we have to come up with solutions. And I'll talk about the solutions we implemented. It's something is quite fun, to be honest. So it's quite interesting experience. If you're interested in hearing that, then listen up. Afterwards, I will talk about preparing the text. This is routine, common text preparation tasks to do before doing any modeling. And these should be standard tasks that you will almost do them all in by following that procedure for every project, most every project. So that's the plan. Any questions? Oh, by the way, homework 4 is up. Apologies for the delay, but I think you still have enough time, 2 weeks, right? And take a look. Let me know if you have questions.
I just tried accessing it and clicking on it, and it said I didn't have access or authorization.
That's weird. On Blackboard?
Yeah.
When did you try it?
Like 5 minutes ago, or 5 minutes before class.
Yeah, same here. I just tried a few seconds ago.
Let's see. It could be a Blackboard thing. Let me see. I don't see any abnormalities here. Homeworks. So it's, okay. Homework 4 is, okay. Let me open that. Yeah, I accidentally hit it. Now, can you take a look?
Yeah, I can access to it now.
Okay, that should be fine, right? Homework 4 is about a few questions about confusion matrix and analyzing the decision analysis on and evaluating binary classification models using the confusion matrix. And green. And then the rest of the questions are about unstructured data. There's a couple questions that I would have not talked about by the end of today, but it will be the content of next week. It's about topic modeling. I think two of the questions, as well as a bonus question. So you have a bonus question. Isn't that great? But don't expect the bonus question to be easy. It's a real challenge. There's serious work to be involved, but if you do the work, if you put in the thinking, you will get it, and it's a substantial amount of points when it comes to the homework 4 total points. All right, let's get started. I'll share my screen. 1 second. Can you see it? Can you see my slides? Great, thanks. So scraping data. Who has scraped data from anywhere? Most likely Twitter, because that was quite easy because they provide APIs. Has anybody scraped data from, or scraping might sound like a bad word. It doesn't have to be bad. So, you know, collecting data from social media, or most likely social media, but some other websites provide APIs. API, application programming interface, a gateway that organizations open for you to legally download data by using their facilities. Anybody? No? I guess that's just me then. Then whatever I say, you will believe me. Huh? All right. That's the spirit. So most of the thing that I say relate to Yelp specifically, but many of these aspects apply to other websites. There are many other examples of successful e-commerce enterprises. They have been around only for 15 years top, 16 years, right? But very successful. And Yelp.com. I also collected data from Amazon. Amazon also provide API, but I think that was a time in the back. I don't think they provide broad API now, but there have been some public data in the past that and I think they periodically publish some data, make data public, available to solicit research efforts. That's the same thing that Yelp did. Yelp put together a data set and invite researchers to analyze the data and think of their own questions. So researchers can come up with questions that can be answered by the data set that they provide. And I don't know what happens after that. There's no competitions, but I guess they just, you know, it's a part of the public relations effort, and I guess promote the data science field in general. So I plan to spend 30 minutes to talk about collecting data and Yelp specifically. So this is just sort of a brief overview of Yelp's Yelp's success. Yelp's data have helped answer quite a lot of questions, a lot of research questions related in the information systems field, information management, information systems field. If you are somewhat familiar with this field, online review has been a big thing. You know, let me do a quick poll. I don't know how to do a poll in Zoom, but simply, you know, flash your hand. Do you use Yelp on the phone or on the computer, on your tab, on a weekly basis? Yeah, several. I already see. I can't see everyone's when I share my screen, but at least, right? Same as you, I do. Weekly basis, definitely. If you count all the weekends, I think on a daily basis. Even with lockdown, we can still go out for necessary expenses, necessary trips. So and this becomes more relevant. We use it more. So, no wonder it's successful. I showed you the Chinese version, right? Not the Chinese version. Yelp is not in China, but the company in China that does basically the same thing. And that company is also present in the States, in large cities. And the reason, because people from China travel to the States and other countries, of course. And they need to dine out also, but they don't know how to use Yelp, at least some of them. They don't speak English. So that's why, in a way, they bring that company to outside. They travel with the company. Yelp's website is clean. It has been clean for all the years that I have dealt with Yelp. I mean, in terms of, when I say clean interface, clear structure, I don't mean simply user navigation, in terms of finding a restaurant and evaluating the food on a daily basis. But that part too is similar implication. I'm referring to this mostly from a data collecting point of view. The source page behind the pages on Yelp has changed somewhat significantly in terms of how the data is stored in the source page. How the tags, how some of the critical tabs, like navigations related, turning pages, and some of the links on the website, the way they write their HTML source code has changed over the years, but overall structure didn't change too much. Challenges is you can get blocked, and you can be thought of, or as a researcher who collect data intensively from Yelp, I can be considered as malicious. I can be profiled as an abuser. I accept that for those small periods of time, but this is the only way I can get the data I need without doing more harm to the company, right? And considering that they have powerful IT infrastructure, the damage is minimal, I consider. So, but anyway, they have to protect themselves. That's fair, right? So basically, two steps of malicious detection and prevention for large enterprise e-commerce websites and servers. CAPTCHA, you must have dealt with CAPTCHA, and this looks like this is Google's CAPTCHA. They use Google's reCAPTCHA service there, and damn, it's good. I say that from a data collector point of view. The better it is, the tougher it is for me, and so damn, it's good. How good? I'll talk about that. So that's CAPTCHA. Have you to click some of these in the past month on maybe on some of the websites? Not necessarily Yelp. I don't think you ever will have an opportunity to see this page on Yelp. Otherwise, I will be deeply concerned about your grades. But maybe on some other websites, when you first sign up for an account, you will have to click something like that, right? Yeah, some of you show your hands. On Yelp, it's rare for you, I think, for a user, for a normal user. So that's a capture. It's easy to, for normal cases, it's easy to clear that. Simply click a few buttons, or sometimes you have to enter the numbers. There's a website that always always have a capture there. It's the Texas Easy Pass, or it's called something else. You know, the automatic payment system that you stick to the windshield, and whenever you go through the tollway, it will, you know, automatically charge that. So that website, when I go there, it's Texas something. When I log in, I always have to put in some numbers. There's a random numbers that generated from the capture behind it. So that's another example. On the right, it's more serious. IP block. So I've had, me and my colleague, we were blocked for 3 times in the past year when we collect data from Yelp, and reasons are different. I'll talk more just in a minute. So I'll talk a little bit about these 2 techniques. Let me set a timer for myself. So capture will show up when my program, my scraper keeps working continuously for about 50 to an hour, 50 minutes to an hour. It will show up. It show up randomly. It doesn't have to be exactly an hour, but around that time. You know, I've been collecting so much data from Yelp during some period. I worked out a schedule that seemed to be working very well, that has a pattern, that it kind of rhymes with you know, whatever is tolerable by Yelp. And so it worked for me and Yelp, I guess. But it took some time to sort of drift toward this schedule. I used to use some other schedule, but when I try to do more, I get more blocks. I get blocked. So that's when I was reminded to be, you know, to be less intense, to slow down. So every hour or so, I will get this. It basically will show that page, not this page, but the capture page. It will show that page every time I open a new page. You know, my program open a new page. So in the data, if I didn't know I have a capture, in the data that I recorded, it will not. I will have a exception, because I can't find those tags, those information, those data I was looking for on those pages, on the capture page. So my program will get exception, and my exception handler will handle the exception. The program will not stop. It will move on quickly to the next page, but all the data in my table will say some weird things, you know, to remind me that the page data collection wasn't successful on those pages. So if I miss that for an hour, my data set is filled with hundreds of rows of meaningless data. No information is collected, and somehow I have to go back and stop the program and restart from the page that I think the capture started. That was quite, you know, frustrating for if I didn't have a better way to deal with this. And you know, initially I didn't know that 1 hour pattern. And later on, after many repeated trials, somehow this 1 hour thing becomes more clear. So I scheduled the program to take a nap, and you know, between each page, I still have to implement some pauses. I can't continuously visit web pages, visit Yelp pages, because after I have been doing that for maybe a week, maybe less than a week, when I was developing my codes, you know, when I test things, I leave it overnight. I leave it running overnight, and you know, after some time, you get captured. After several days, it not only get captured, but the IP is blocked. So that's when I start to implement pauses. In the end, the best solution is irregular pauses. I think I will talk about it in a second. I use a random number generator to generate a number of seconds I should wait, and then I wait based on the generated number. So that's capture. If I slow down, capture will appear regularly, but that's fine. It's only once an hour. If I timed it well, then I can manually clear it, and the program can go on for the longest I've done is, I think, 26, 27 days. Every day I can collect close to 5,000 to 6,000 rows of data, each row being a review. So each day I collected 5,000 or 6,000 reviews data. That's quite a lot. And after 23, 24 days, I collected everything I needed. So without being blocked. Capture, sure, every day, every 1 hour or so when the program is running, but things are fine. Capture, of course, you can say, you know, why don't you use programming to deal with capture? You can dare to challenge Google, Yelp first, and turns out Yelp use Google service. You can dare to challenge Google, but I don't think it's that easy. My colleague tried to do that because there are some information online, people sharing experiences of how to go around capture, Google capture specifically. But what happens is if you use programming to do that, somehow Yelp finds out, or maybe Google finds out, and they show you something different. They show you this. You know, recognize the school bus in the pictures and select them and verify that you are a human. We don't have something that can take this. And it's not worthwhile to even try to train something to deal with this. There may be something available on the market that we can buy, but I think Google will seriously go after them. It's not something that is considered ethical or even legal. So, but anyway, the challenge of capture will escalate very quickly if you try to use programming to deal with capture. So in the end, we just gave up. We use manual, you know, the dumbest way, which turns out to be the smartest way to deal with it, you know, within the limits. And I don't even know after this step what will happen. You know, I wonder. Somebody must have tried, but who knows? But if the data scraping becomes intolerable, Yelp will block. My office IP was blocked think that was my office IP. And later I had to use VPN. So my office IP was blocked after a week, overnight scraping every day. When I didn't use the irregular pauses and naps. So, you know, try not to be too aggressive when you collect data from powerful websites. The process of collecting Yelp data, every project is different. It's guided by the objective, and objective is guided by the research question. So the reason we collected Yelp data, of course, is not limited to this research question, but it's prompted by this research question. And we figure that, you know, given this research question, we collect the data, and the data may enable other questions to be pursued, as long as we do a good job in, you know, collecting rich information. The amount, when you collect data from web pages, you know, the time that it takes to collect 2 pieces of information from the page versus 20 pieces of information, it doesn't make a difference. The time it takes for the program to grab the page, go through the source codes and extract the data, as long as there is no exceptions, the time is almost the same. As you can think of, computers are fast. The only difference is the time that you spend in building a scraper that parses those pieces of data from the source code. That takes some time, but the moment that you figure out the structure of the HTML source code and figure out how to use the various packages to parse those data, then it takes less and less time for you to add an additional piece of data in your scraper, because, you know, you already, once you know how to do multiplication, you can do 2 multiplications very quickly versus 1 multiplication. You know, the greatest amount of time for you is to learn how to do multiplication. So, you know, your work can scale up quite quickly. And also, just as a sort of a best practice, always remember to save the source code as a text file after you have crawled 1 page, because you never know, there might be a piece of information on a page that you didn't think of, but later you want to collect it. So you would rather have those source codes, and they take some space, but nowadays the hard drives are so cheap. I think 26 days of Yelp data, I think it comes down to at least millions of pages I have visited. The millions of pages, source codes as text files, they maybe take several Gs or maybe 10 Gs, something like that. It doesn't take a whole lot of spaces. But moving the files takes forever. So you need to learn how to deal with a large amount of thousands of files in Windows. It's not very efficient to move. So better to zip them and move. If you move 1 by 1, you know, it takes days. And that's it. So save the source codes of every page that you parsed important information, so that you can revisit. You know, when you revisit, you are not limited by Yelp. So you can process millions of files continuously on your computer, as long as the computer doesn't die, right? You are not limited by Yelp. If you had to recollect the data again to revisit those pages, it takes a month. So it's a day versus a month. That's the difference. To collect the data from Yelp, to answer the questions we have to collect detailed review-related information, including the star ratings, review texts. We want to save review texts just so that we might be able to do some text mining. And I also, excuse my son, and I also saved all the URLs of those pictures that the reviewers uploaded to their reviews if they did, so that we may do some picture analysis. All of these things are possible to answer the question. We just save them for the future. So to do those, I have to first get a sample of restaurants, businesses in general. Restaurants are called business on Yelp. And for each of the business, I have to get their reviews. For some of the projects, we simply collected all of them because we don't have a long list of businesses. I also did another project where I collected the reviews for hospitals and clinics because there are not many hospitals and clinics in those areas that we're interested in. We just collected all the reviews, and they are not very many. Hospitals are a minority service on Yelp. Restaurants may be the largest number. But fun fact, when I looked at the Yelp website, their advertising revenue, the biggest chunk of advertising revenue is not from restaurants, even though restaurants is, I guess, the #1 category of businesses. But I guess restaurants don't do much advertising because they are mostly local businesses, I guess. But the #1 category of ads revenue for Yelp is almost 40%. It's local, it's other services, maybe tech services, maybe some other services. I don't know. But I thought it's quite interesting. So to collect the detailed review data, we have to have a list of businesses. Our research is centered around geographic areas. So we started from compiling a full list of zip codes for Dallas and Houston areas, every single zip code within a radius. And then I developed the first scraper to go through all the zip codes and search restaurants as a keyword and collect all the businesses that's returned from the search for all the zip codes. And then the second scraper is developed to visit each of the business review page and flip through the review page one by one for all the businesses. So here is a roadmap. This is just for your reference. If you ever in the future will collect data from Yelp, and even if you don't collect data from Yelp, maybe some other website, you can use the same process or similar, right? So the first scraper, get a list of restaurants by using zip codes. So zip code and restaurant are the two key search terms. We got a lot of restaurants. And I found that, I realized that for most of the restaurants have probably 10 pages of reviews. So 10 pages is like 200 reviews, or maybe 20 pages, it's 400 reviews. Yelp displayed 20 reviews on each page for whatever business, for whatever, I think business. So it's a fixed number of reviews on each page because the review do get long. Some of them have photos. So Yelp doesn't want to display too many reviews on each page. Most of the restaurants do not have more than 20 pages of reviews, but occasionally you have these stores, restaurants that have thousands of reviews. For Texas and Dallas, it's mostly taco, food, what do they call it? Streetcar streetcar or food car that, you know, it's
Food truck.
it's a yeah, food truck. It's a mobile, you know, mobile restaurant kind of, and they get reviews. Interesting. And they get thousands of reviews. So Yelp will stop displaying any review beyond 1,000. That's what we discover, because, you know, I see these popular restaurants. When I look at the data on those pages that are beyond 1,000 reviews, that's probably, you know, beyond 50 pages, right? Because each page shows 20. Beyond 50 pages, I don't see any data, but it's taken time to flip through those pages, and the scraper has to take pauses in between each page. So it wasted me a lot of time without getting anything. So later I improved that, you know, scraper stops and move on to the next business as long as it hits 1,000 records. You know, learn quite a few things through trial and errors. So that's it. I mentioned most of these data are in the data set that I do the demo, but some of these are not. And, you know, because it's not that relevant to the exercises that we do. And I don't want to keep some of the data, you know, private. And I take a sample from the larger data set. So tactics, right? Tactics to deal with the capture and IP block. I have a few minutes. To avoid IP block, I use I set the upper limit for time of that the scraper can go, and I use random pauses in between. I use a log normal distribution. If you know, log normal has a long tail, so that most of the jaws are in the hump area between maybe 1 to 10 seconds, so that I don't draw large numbers very often. But occasionally I could get large numbers, but I will keep a cap on 15 seconds. So that, you know, for Yelp, if they were to analyze this suspicious user that who visits thousands of pages restaurants, you know, this guy must be very fat. When Yelp reviews my behavior, it may seem like more random, like, you know, more similar to the way that we use Yelp. We don't visit Yelp every 3 seconds like a machine. You know, I look more human in their profile, so that at least will lower the likelihood of me being blocked. And every 15 minutes, I will put in a 10-minute or 15-minute nap that programs that does nothing in those time. And one thing it does is actually it allows Yelp to kind of start activate the captcha. I don't know how, but it's if I keep going for 15 minutes and more, you know, if I keep going for an hour and 30 minutes, somehow the captcha is not kicked in sometimes. But if I go for 15 minutes and take a nap for 10 or 15 minutes, the next time, you know, after the nap, when the program resumes, it will get captured like almost always. So it sort of, I don't know, weirdly makes it easy for Yelp to activate that capture. But that's good, because as long as I get capture, I can clear my, I guess, I can prove that I'm a human. so that, you know, Yelp does not become more suspicious. So as long as you do these, you will not be blocked. And then tactics to deal with capture manually. That's the dumbest way that proves to be smartest. But we still use, so initially I didn't know what to expect. So I have to remind myself to check back every 1 hour. Sometimes I see capture, sometimes I don't see capture. But when I see capture, that means some of the data are already lost and program kept going on. I have to stop the program, manually find the point where capture started, prevented data collection, and restart the program from that point on. It's quite laboratory. So, so later I improved the program. What I did is we have a checkpoint where on every page that's returned, we check if that's a capture page. If that's a capture page, we pause the scraper, do nothing, because even if you do continually visiting pages, we're not getting data and it creates more trouble. So why not pause it, but don't stop it. You know, stopping or restarting disrupts the process, but pausing is fine. And then when we found out the program is paused, we will manually clear the capture and restart the program. What you can do is you can, when you pause the program, you can put in a user input prompt so that program is stopped. But then when you want to resume, you input anything. Program can discard any input. You can program your scraper like that, and you can scraper can resume collecting the next page as long as user provided input, right? So that your program don't have to stop. But still, the problem is, how do I know when the program has detected a capture? So in the end, what I found that I can use one of those, you know, automatic texting service that's provided. And I found this service, Twilio, that some of you might know. If you invest in stock, Twilio is a public company that that IPO'd maybe 2 years or maybe more than 1 year ago, and the stock climbed quite well. You know, I regret that I didn't buy stock from this company from the day that I discovered its service. The service is quite good. I was given a $15 certificate when I opened up the account. I still haven't used it all because every text costs 1 cent. 1 cent. Or less than 1 cent. Every time my program detected a capture, it will text me. It will alert me. Once I receive the alert, I go to my computer, I clear the capture manually and just wait for the program to resume again after the nap. That has made such a difference. I don't have to keep watching my clock. I can do my thing, and I only have to pay attention when I receive a text. So this way I can run the program efficiently throughout the day for 12 hours. And in 12 hours, you can collect 6,000 reviews, somewhat like that. So this is the best practice that I, you know, that I have. I think that's it for Yelp data collection. Any questions? No questions. Are you all very amazed? All right. Now, so let's talk about the next item on agenda, preparing the text data after cleaning. Last class, we did the cleaning part. The cleaning cleaning part is necessary if the text data is collected from online sources, websites. You know, one of the textbook, the PML textbook, used examples from public data, but that public data was collected from IMDb, the review, the movie reviews, and it's rather cleaner. It's quite clean, but it still has some HTML tags in it, so it requires some, you know, regular expression. Yelp data also has these weird symbols, but they have a pattern, so we could use regular expression to deal with that. There will be some homework questions on that, and so Uncertain mostly based on the lecture, last week's lecture, the demonstration I showed. You know, try to find a pattern and use the regular expression. So after that cleaning, you have cleared almost all of the weird symbol strings. Then what's left is basically clean review text, besides a few issues, you know, minor issues that is because of the cleaning. For instance, if the review says, I will, you know, after cleaning, it will become I space LL, because you have replaced this symbol becomes ampersand something pound 036 semicolon. So you would have replaced it with a space, and so it will become something like that. You will have a lot of these things. And whenever there is apostrophe S, you will have a space in between. But even if that's a minor issue, even if that's an issue that makes reading more difficult for text mining algorithms, these do not create too much trouble. And you know, for useful, valuable information in the text data, these don't add much value to the patterns that you may extract that can link to some behavioral outcomes. So they are minor issues.
Hey, Dr. Ma.
These issues will be cleared when you prepare the data set. Yeah, Efrat?
Yeah, quick question of the apostrophe. Why does it get transformed into the ampersand number symbol 036?
Yeah. This is because in HTML, I'm not an expert. This is my speculation, but it has something to do with HTML code. In HTML, when let's see, when users input these symbols into the text box, and Yelp server will capture the data and store it in their database, they decode it, or they encode it in this way. And this is so that when Yelp displays these symbols on their page, they can correctly decode it. That's most likely it. That's human language I can put together to explain this. There is, you know, when it comes to symbols, that's the messiest part of the text data to computers, to programmers. So that's one of the challenge. I used to hate to deal with these, but now I have to deal with these. So I sit down and think about patterns, and I can deal with these. But as long as I can clear these away, because these are not meaningful, you know, even if it's a term that's recognized by TextMiner, it doesn't add much value. You know, this is more stylistic features of the language that doesn't add information or too much information to the problem. So, make sense?
Yes, thank you.
Right. So after the data is cleaned, how do you prepare it? A list of things, 5 things mostly, a list of things that you need to do. And let's, these are new terms if you haven't dealt with natural language processing. I'm talking about the term that you must have heard, NLP. What does it mean, natural language processing? What does it really mean? What kind of stuff do you do? These are a list of stuff that I'm going to talk about. These are new terms, new vocabularies. You need to understand these. Tokenize. Tokenize is to make tokens. What does token mean? Terms, basically. And in NLP projects, we mostly use 1 gram. 1 gram means 1 word, 1 term. Is in English, in daily usage of English, a word is a gram. Most programs use 1 gram because it takes least amount of computation power. It's the most interpretable and least complicated, but still it gives you good results in some cases. So, so we don't bother go to more advanced, but you can do 2 gram pattern too. So every consecutive word bundle become a unit. So the unit is not simply by word, but by 2 word bundle. And if you believe the 2 word bundle gives you additional information, then you should model by using 2 gram. Otherwise, the bag of word is mostly based on 1 word analysis. 1 word as a unit. So tokenize means to break the chunk of text down to elements of words, right? So that's tokenize. You have quite a few packages that can do that. I'll talk about that in the next few slides. So that's tokenize. Lowercasing. Lowercasing is easy to do. It's very easy to do. You probably know how to do that if you went through advanced programming course. It's a method of a string, so you don't even need additional packages. But lowercasing is critical. It has benefits that is often ignored, or you probably don't realize it when you're beginning to learn how to do NLP. Lowercasing avoids the sort of the surprises where you get every sentence has the beginning word as uppercase, right? So if you have apple and smaller lowercase of apple, if you don't convert this to a lowercase, to Python it's 2 different terms. It's 2 completely different terms. Python doesn't understand capital apple is just another use case of apple. So convert it to lowercase avoids a series of problems similar to these. If you keep it as capital, maybe it's not only just another term. What happens is when you construct the feature vectors, each term is an additional column in the feature vector matrix, and it will become a giant matrix where each of the column is a new term. You can have over 10,000 feature space very easily. Using the Yelp data, you have 20,000 feature spaces if you keep everything in it. So, and for something like these, you know, a word that is capitalized because it's at the beginning of the sentence, it creates additional column with very few one, which means very few of the text we call document, very few of the document has this word, capital Apple. So a few of them have it. So it's a very sparse column that doesn't add much information in it. And let's, you know, realistically, it adds zero information, but programs doesn't know that. Program thought this is additional information, but this new column with mostly zero eats up more resource, more memory, and more computational power without adding anything, right? But you don't have to get rid of that. Converting it all to lowercase does the job. So I recommend that you do lowercasing as the very beginning step, the first step of preparing the text. Then afterwards, you don't have to worry about that. Packages, because it's very important, a lot of the methods in the popular NLP packages have a lowercasing as an argument, so that when you call this function, you specify that lowercase is true, it does a lowercasing for you. But it's not a good practice to delay lowercasing until when you do the modeling step, because you would have created, I guess, trouble when you prepare the data. You would have created noises in some other steps of the preparation I'm going to talk about when you don't ignore the cases. You know, making them all lowercase means to ignore the original cases, and that's good. All right, let me clear these. And when you tokenize each word, you know, each word is broken to a unit, and sometimes you have very long words with 20 characters, and you have a lot of other cases you have words with 2 or 1 letter. These words, most likely they fulfill a I don't know, transition purpose, or purposes in linguistics that don't add meaning to the communication. It mostly makes it easier for people to understand the context, you know, or transitions. So these words, you can safely remove them. As for how to pick the numbers, the lower bound may be easier to figure out. 2 or 3, that's fine. If you want to leave words with 2 characters and only exclude those with 1 character, I think it's fine. Most of the 2-letter word may eventually be dropped because they are stop words. I'll talk about stop words, and stop words definitely don't add value to text mining in most cases. So this is easier to pick, but how do you pick 15? Is 15 the best? You have to think about your context. For most common, I guess, most common projects where you analyze texts that are generated by normal people on subjects that are common interests, then 15 is adequate. You may even use a letter that's smaller than 15 to really focus on the good majority of the common words. But if you just want to make sure you don't leave out occasionally important things, you can choose a number that's a little higher. 15 or 16 doesn't make a whole lot of difference to your projects. And here is a distribution of the common words in the texts that are generated by people. Distribution of the words with various counts of characters. The bound that I put was between 3 and 15. These numbers is just a replica of these numbers. It's the length. It doesn't mean the frequency. Frequency is under the count and percentage, represented by the bar length. So between 3 and 16 is what I said. If you take a look at if you add them all up, they represent close to 99% of the words. For more information, look at this page. This person did the analysis and published the results. So I would say 3 and 15 as the minimum. So 3 will be included. That's the minimum. 15 is the maximum length, or adequate, or good choices. They don't have to be the optimal choices. You know, it depends on the specific projects, but most cases it's fine. You know, projects that analyze Twitter messages, definitely fine. Twitter don't even allow more than 240 characters, so you can't be very verbose, or I mean hard words. But for other common projects with common topics, should be mostly fine. So I talk about tokenizing, lowercasing, and extreme length. And stop words, mention stop words. These are stop words. Stop words doesn't have to be very short. Some of them are longer, but it doesn't, I think even however is maybe a stop word. You know, they fulfill the stylistic or transition purposes. They don't add much value. Even if you use however a lot in your writing, it doesn't mean it's adding value. It even, you know, counterintuitively, it means a contrary. It has to add some value there. Well, computer thinks otherwise. They have picked up better signals because you have to say something after however, and those information might be even more important. So the transition words doesn't add much value considering all other information. So for a list of stop words, you can take a look at this website. Thousands of resources online you can check. And even though there may be variations from one source to the other, most things will overlap. Stop words, you have standard packages that have this resource. NLTK has it. The book talk about NLTK. I'll talk about that later. NLTK has it. GenSim, which I recommend for preparing data set, has it. It's a collection. You simply import it. So removing stop words when you do tokenize. Finally, the word status or word form. It's called lemmatization, or sometimes stemming is used instead of lemmatization. The two have some differences, but I recommend lemmatize, given it does require more resources from the computer. It takes longer, but given the computer equipment that we have, and it's going to be cheaper comparing to the size of the data set that we typically deal with, it's considered the better option. If in some, you know, rare cases you are dealing with so much data that lemmatize becomes a bottleneck, you can switch to stemming. Won't affect the results too much. Some may argue stemming gives better results, but I think that depends on the specific project. It's hard to generalize that conclusion. So I favor lemmatize. The benefit of that is that it doesn't create bizarre word. It doesn't create non-existing word. When word is when stemming is applied, some of the sort of the original shape of the word is not preserved, but lemmatized will do it properly according to the original form, the base form of the word. It will do it properly, so that, you know, sometimes when you use verbs as ing form, like increasing, lemmatized, this is L, lemmatized will convert it to increase. But when you do stemming, it will simply truncate the ing and leaves you this. This is a word that's not recognized. So when your text has both increase, like increases, it will be properly stemmed, that's fine. But when you have both increases and increasing, after stemming, you'll have increase with E and increase without E, two unique words to computers, but the same meaning. When you use lemmatized, it will be the same word. It will return the same words, so that computer will recognize. Stemming does that. It removes the various sort of the status of using the word and return it to the base form. What it also does is it adds a POS tag, part of speech tagging. This is the natural language processing language, a jargon. You know, but with some simple examples, you can understand what that is. So after lemmatizing and POS tagging, each token, each word, basically 1 gram token, each token will be returned to the base form, and it will be accompanied with a tag. And there are 4 basic tags in simplified POS tagging. You must have learned it. Half of the class is international students, I think, same as me. We treat English very seriously. You know, English book is like a Bible to us. We read them over, and we recite them, we remember them, we try to memorize the passages, the grammar, everything. So these look very familiar to me. I don't know about Americans. But I think my son is learning that now. So you have 4 basic word class. You have now is you, me, you know, ball, baseball. Verb is when you do something, right? Adverb is to describe the word, to describe the verb, the action. Adjective is to describe a noun or a situation, right? And the code that Gensim, as well as many other packages, use for the code are like these. So all of these correspond to the category above it, right? So let's do some examples. In this sentence, George knows how to fish and he eats fish every day. There are 2 word fish, twice. They spell the same, but they have different tags, right? What's the first tag in blue? And the base form is fish, of course. So who can tell me what is this tag? Is it noun, verb?
Verb.
Verb? Yeah. And second one. Okay, I won't ask you. The second tab is a noun, right? So when you have the data, I mean, after lemmatization by using Gensim, you will see fish. I mean, this is text strings, of course. fish/VB, you'll see this fish/N. So that's the result output of the lemmatized task operation. Let's do another thing. Lemmatize and tag each word. So lemmatizing means the first part of it is return it to original form. Get rid of the specific casing, I guess. So, you know, get rid of the ing, get rid of the past tense, return it to the original, to the base tense, base form. And here, the is quite interesting. It's a special kind of verb. It's still verb, but it's a special kind of verb. It has a different, it has various forms, right? Is, are, were, was. I think that's it. Right. So let's do that. You know, do it in your mind, or you can. Do you know the base form for is? Who knows? Or let's start from Python. Let's say Python, return to the original form and tag. What is it? Noun, verb, adverb, adjective. Anybody?
I think it's a verb.
It's a verb. Yeah. Python, verb, NN. No, sorry, not verb. Noun.
No, Python is an I was talking about.
Yeah. It is a verb, yes. But what's the base form?
BE.
Yeah. So all of these, the base form is B. Okay. It's verb. Extremely, the base form, and the tag.
Adverb.
Oh, yeah. Adverb and base form. It's the same.
It's same, yeah.
Extremely. Right. Don't remove this part. It becomes adjective. Right. It's not supposed, lemmatization is not supposed to change the type of word. It's only supposed to return it to original form. But it's very tempting for me to get rid of the ly. I don't know why. I think I overstudied English. Anyway, enjoyable. That's the only thing left, right? Enjoyable is an adjective. It's JJ. So these four words each take a different tag. There are only 4 kinds of tags in Jensen. Python B, extremely enjoyable. Eventually, B will be dropped because it's a stop words that I talked about. So that's it. So we have lowercasing, tokenizing, extreme length is stop words, and lemmatization plus the POS tag. So let's talk about packages. Right. The book recommends NLTK. It's a good, comprehensive, rich package. It may not be the best choice for all the occasions, especially when you are dealing with quite large text. I think the text that we're dealing with is quite large. It's not a trivial size. 10,000, 15,000 records, each with a review text. Review text may be on average on average 80 letters, 90 characters, maybe more than that, maybe 200 characters. We can take a look. We can easily calculate it. So the package I recommend, in fact, that's a package that I use in a recent project I do that involve a little bit of LDA that I'm going to talk about next week. Involve LDA and LDA analysis, bag of word models, and I use that because it possesses some of the great features. Some of them are mentioned here. A good feature is that you can do online learning, and you don't have to restart the learning when you have new data. So that's the best part. It's similar to the Keras model. When you train neural networks, sometimes you find out that the number of training is not enough. You need to train 10 more epochs. You didn't have to restore and retrain whatever is trained. You can simply add 10 more epochs. It's the same thing here. When you have new data, you simply update the model by running over the new data set, and that's it. And the best part, this is unsupervised learning. So the bigger your pool is, the pool of data training set, the bigger the training set, the better the results, because it's unsupervised learning. It's different from supervised learning, right? But it's limited in terms of language. You know, it's very capable in English, but when you go outside the boundary of English, when you have to deal with other characters, French characters, Chinese, then good luck, you know, because the main body of developers here mostly use English. So that's how they can go deeper. I guess they can be more efficient by focusing on narrower targets. So for all the demos I include to prepare the texts, I use Gensim. But when we deal with the models, the LDA model, bag of words, I still use scikit-learn because that's easier. It also does provide models, LDA models, and other advanced text mining models, but it uses different terms. So I thought it's too much learning for you guys. So better stick with the book. So for the models, I mostly rely on scikit-learn. Okay, so we'll use Gensim to mostly prepare the text. I will demo individual steps, you know, these individual steps, and then I will demo the pipeline approach, which includes all of them. The demo should take, you know, maybe 5-10 minutes. So let's fire up not this one, this is next week's topic. So let me turn up the Jupyter Notebook. And let's see, to make it easier, I will switch window only to the Jupyter Notebook. Can you see it? Do you see it?
Yes.
Yeah. And can you read what's on the screen? You can? Great.
Yes.
All right. So let's see. You know, import these basic packages. I've already done it, so I won't run these. Import the random seeds, not that relevant here to the demo, but you know, for safety, just run that if you want to follow along. We'll start from learn to prepare text. All of these I demoed, mostly using regular expression to clean the data set, using the sample. Let's see. Let's see. Right, using the example strings. And here, oh, yeah, when I demo these individual steps, I will use a sample string. So lowercasing, this is the example string. It's a long string, right? And after each print, I will print out the string after I perform each step. But when I print the texts, it will not break each line properly. It will break the word. It will not properly recognize the word. So I can copy that and put it into a markdown. Markdown cell will properly break the line so that it doesn't break the word, make it very nice to read for reading the content. So I do this every time I print out large texts. The package GenSim will mostly use, there's a stop words collection, we'll use that. And I will demonstrate simple tokenize, but later we will stay away from that. We'll use simple preprocess that includes a function for tokenizing, but simple tokenize is to demonstrate that particular step. Lemmatize is the last step, right? And in the end, we will, and strip numeric is another function as part of the pipeline. I didn't single it out because it's straightforward, simply strips away the numbers. And preprocessed string is a method that can be used like a pipeline. And I'll get to that. The first part is lowercasing, right? Lowercasing is by using the method of string dot lower, don't forget the parentheses, and then it becomes lowercase. So I get the string S, convert it to lower and print the results, and I copy paste into markdown. The text didn't change. If you compare this cell to this cell, the text doesn't change. The only thing changed is the capital letters. But also notice something that when hold on, I was going too fast. So lowercasing didn't change anything else other than the capitals. I mentioned earlier that each review text may have 200 characters or so. We can find that out. So I want to do that. I will jump to the Yelp data, right? We'll import the Yelp data and take a look at the data set overview. I have 12 columns. Well, a lot of these are ID columns, are meaningless to us, but a few useful columns. Very few missing data, but somehow there are some missing data in the user address, user location part, but doesn't impede our analysis here. The column that I will mostly focus on in the demo is review texts. 15,000 records, and it's string. So let's find out how many, typically on average, how many characters are in each review, including, this is counting everything, including the punctuation, without doing any preparation here. So how would you do that? Think about that. And I will just do it live here. Once you read in the data set, you need to have develop some codes to calculate the length of the texts and somehow calculate the average. So how do you do that? Without using a for loop. I discourage using for loop on things that you calculate on data frame. Better use the one of the data frame methods that implement loops more efficiently internally without using a for loop structure. So you basically are counting the length of the values of each row of that column, review text. So how do you do that? Anybody has already solved it and want to volunteer your answer, your approach? This is not something that I will include in the homework or test. This is for fun, for anybody who's interested that has not taken the advanced programming class, and you want to know how to do that. And plus, we'll find out something something about the data set. So how would you do that? Typically, we will get the column, get the series. This is a series. And by calling a method of the series to apply a function on each of the element, and it will, and then, so it internally it's a for loop, but it's a for loop that's taken care of internally, increase the efficiency. Then it will output a new column with the results filled into each of the element, as your result. So whatever your function is, it will calculate the result from each row by using information about the review text, and it will return a new series, a new column of data, which is what you want to calculate. Your task here is to calculate a new column that calculates the number of characters of each of the review texts in each row, right? So number of character as the column name, I guess. So how to do that? How to count the number of characters of each review text on each row and get the result for the entire column. Any ideas?
Can we use a Lambda function?
Yes, definitely Lambda function. Wait, hold on. Do you have to use Lambda function? Do you have to use a Lambda function? No, you don't have to, but if it's easier for you, you definitely can use Lambda function, yes. A Lambda function is sort of like a advanced tool, but it's very helpful, right? It's even in some of the demos, but I'll talk about that. So, but only using Lambda function is not enough. How do you apply Lambda function or whatever function that is adequate here? How do you apply that to all the cells, all the elements? How do you apply element-wise function call? There's a method that you need to use for the series. Do you recall? Let me give you a hint.
Is it for loop?
Yeah. What you need is a loop, definitely. You need a loop to calculate the same function across all the elements of a column. But instead of programming a for loop explicitly, it's better to use the apply function of the column that will invoke a for loop internally. That's much more efficient. Yeah. So within the apply function, you need to give it a callable function. And here the purpose is to calculate the length of the text value. So the length function is a callable function that you can provide to apply. So that would do it basically. So if you run this and you run the describe and to get the mean, right? Mean is 506 characters, much more than what I imagined. Much more. So what I did is I use apply function to apply a function element-wise. Length is the function I apply, which calculates the length of the texts in terms of number of characters. It returns a series. It returns a column, number of characters, and this column has a method. Any series has a method, as long as it's numeric, has a method of descriptive statistics. I get it. I round the numbers. Typically, it gives me 6 or 7 digits. I don't want that many. I round them to be default is 1. Default may not be 1, but default is very small, and maybe zero digits. Anyway, after that, I only extract the mean statistic. It gives me the value. So Lambda function, can it do it? Definitely. So with Lambda function, you still have to use the dot apply, because that's a for loop mechanism. That's a loop mechanism. And here you can provide a Lambda function. The format of Lambda function is lambda whatever. This can be whatever, as long as you use that as a variable name. And X is, I think, a typical thing that people use. So lambda X colon, and you have to write something that will produce a return. You can do X as well. What this does is it will return a copy of X, basically. But the reason you use Lambda function is you want to do something about the X. What is X? X is every review text. And the apply function will apply it over all the elements. So what do you want to do with X? You want to calculate the length. So that's the way you use the Lambda function for this purpose. And this code will produce the same result as the above. You can test, right? So it gets the same statistic. So turns out that the review lengths are much longer for restaurants. On average, a reviewer will write a review that has 506 characters long, including the symbols. Even including the symbols is quite long. Assuming each word is 8 characters, then it's 70 words. No, it's 60 something. 62 words. 62 words. 62 words. How long is that? 62 words. That's okay. Yeah. People are willing to spend that amount of time to write reviews. That's quite amazing. All right. Return back to, let me use the hyperlink here. So let's work with this long string, and we can see the results quite clearly. Lowercasing does this. And the next step is tokenize. Simple tokenize is a function provided by Jensen. It's a regular tokenizer, and how to combine the lowercasing with that is you simply wrap the lowercasing function inside the simple tokenize, and you can get the result. But the result of simple tokenize is not text. It's not even a list of texts. It's an iterable, I think, or it's something that will return the result if you call the result. So, but you can treat an iterable as a list, and you can use the string function to join them. So you treat that as a list. You use space.join this list, and it will provide you the text after being tokenized. So if I tokenize them and then use space to join them together, didn't I do nothing? So I break it down to tokens, and then I use a space to glue them all together. Does it become the original text? Yeah, think about it. And I copy the same text here into Markdown so that we can read it comfortably without word breaks. Think about what's different between these two versions. What has been dropped? What does tokenize do?
Has removed the numbers and some other signs like the apostrophe.
Yeah, so those are punctuations, right? So tokenize removes, tokenize should remove punctuations, and it removes those spaces between the words, right? And put each of the token without punctuations, typical punctuations, but unique or not unique, punctuations that are not typically, that don't typically appear will remain, because common tokenizers won't recognize them. But there are only two scenarios. One is special character. They add meaning, like, I don't know, like other things. But another scenario is there are symbols that you are supposed to clean them in the first step, but that wasn't cleaned, unfortunately, so they remain in the text. Then tokenize, and tokenizing didn't take care of it. So two scenarios. It's supposed to get rid of all the common punctuations, and it did. It's not supposed to get rid of the numbers, but it also did. But anyway, getting rid of the numbers don't harm the meaning of the texts. To programs, the numbers don't make much sense to them in terms of linguistic, in terms of unique information inside the text. So that's that, but we will not use simple tokenize in later steps. This is simply to demonstrate what a typical tokenizer will do. We will remove the extreme length. We use a simple preprocess function by Jensen, and later we will use this as well. This is part of the pipeline. Simple preprocess does two things. It tokenizes, and it can remove words of extreme length. You specify the lower limit and upper limit. Even if you don't specify it, there is a default. The default lower limit is 2. So I override that to be 3. Max limit, upper limit is 15. The default is 15 as well. So it takes care of that 2 steps. By using the lower, you add in the lowercasing. So by one function, you take care of 3 steps here. I use the original string. I does 3 things in 1 step, but know that after simple preprocess, it's the same thing. It returns it returns an iterable. It doesn't return strings specifically. So you need to glue them together. So that's what happens. And I'll copy the codes. It's here. So words of extreme length has been get rid of. And words that are 2 characters or shorter are removed. So things like of, I, to, of should be gone. When you examine the results, they are not there. So that's combining the first 3 steps. Any questions so far? I think it's quite straightforward. All right, let's keep going. Removing the stop words. There are different approaches. Here, I demonstrate the list comprehension. It's another advanced topic of Python programming in terms of dealing with data and also for general purposes. But it's also quite very useful. Every advanced function is very useful. I don't know why, but it's worth spending some time to understand how that works. And it's not that difficult, but takes some time to adjust to the format. So basically, I think, let me write out something here. Okay, so you can see the Jupyter Notebook, right? You can still see the Jupyter Notebook, right? Okay, great. So here, this cell is list comprehension. Here, I demo I use a example string. I use the same example string, but I extract those stop words after doing lowercasing. I use a simple tokenizer again so that I will return those short words with extreme length, so that you can see clearly all the stop words in this. And this is list comprehension. It returns a list, and it does several things in it. Basically, let me share my other slides. Okay. So a long word, but it's still shorter than 15 characters. So it's a common word. List comprehension, what it does is it simplifies a for loop. So basically, if you typically, when you do a for loop, a typical use case is that you need to go through an iterable, process every element of that iterable, and return some transformed result of each element and put in another list. So in the end, you get a list. So typically your procedure is 4 steps. You define a new list. Is an empty list, and it's there to store the results. The first line, the second line, you do a for loop for everything, for I in a collectible, something that you can iterate through. The third line, do something. And give it to the result. R stands for result. That's for every element of this iterable. And the last step within the loop, this is within the loop. This is indentation. Within the loop, you put that new result to the list. So that completes everything. And by the end, this is outside the loop, you will examine new list, do something. With the 4 steps, you can concisely do it in one line. That's the beauty of list comprehension. What you do is, the first and foremost, you create a list notation and write everything inside. But in the end, you will assign this thing to new list. Right. So everything here, including that, but this is not explicitly written, everything in line 2, 3, 4 will be written inside the list comprehension. You typically go like this. So for I in the collectible, do something here. You don't have to assign to something because the output of that will be automatically put into this list that becomes, that's it. You don't have to do the append because that's automatically done. That's the beauty of list comprehension. In many cases, you need to do an if statement inside the loop to, invoke this condition. Only if the condition is met, you do something about that element. Otherwise, you ignore that element. That's common. So if that's the case, you can very easily incorporate that without adding another line. You add that after the collectible if condition here. So that's a rule of list comprehension. After some practice, you will ace it. I have no doubt. You can, you'll find that more and more codes, more and more of your development can be taken care of by list comprehension. So, encourage you to start using it more and more. Any questions? So this is kind of a deviating a little bit. Any questions? List comprehension? No? Okay, I'll go back to the demo. So here, this is exactly what I explained. For something in the collectible, and this collectible is the combination of the first 2 steps, lowercasing and tokenizing, and it returns a collectible. You can do for loop. You can glue them together, or you can do a for loop. You can loop through it. It can be done. So for every word in this collectible, only if word is in the stop words. Because I have done the lowercasing, the stop words collection, the set is all lowercase, so it should be fine. Otherwise, some stop words may be ignored. Sometimes you have a beginning A. A deer has just passed by. That A in the beginning of the sentence, if it's uppercase, it will be ignored. And so that's bad. You want a lowercase as the first thing you prepare the text data. Every element of the collectible that matches any of the stop words, it satisfies the condition, I will retain the word. I don't do anything about it. I return that copy of the word. So by the end, I have a collection of the stop words found in the string. This is the whole list of, it's a lot. It's quite a lot, right? Computer, that's interesting. That's interesting. And become. But most of these are expected. Most of these don't add much value to text mining. So So that's a practice, but now I need to retain the words that are not stop words. So I want to remove stop words. Hold on, this is a demonstration of the equivalent codes. If you don't use list comprehension, you need to have 4 lines, right? You need to use 5 lines. So same thing, but the purpose here is to remove the stop words. So what I do is I change the condition. Only if the word does not match anything in the stop words, I will return it. I will retain it in the collection. So in the end, I get a list of words. Then I use the space to glue them. It becomes a long text. And now with the stop words removed, so copy the line. And lastly, let me quickly go through this. Finally, I will do the lemmatized. I will use, again, I will use, let's see. So lemmatization has some trick. Using the example sentence, Python extremely enjoyable. We do that. We have Python with tag, B tag, all the tags, and the base form is the same as we analyzed, but we have these bits, bytes, literal. It looks like string, but it's not. So we need to decode it and convert it to strings. So we use the string method decode to decode it. So it's an extra component in the codes. So I won't explain the codes in detail, but I think you should be able to understand them. Let me know if you have questions. After decode, the bytes literal is gone. What's left is the strings, and don't forget to glue them together. So let's see. So that's what I get. So after preparing, you have these word plus the tag, word plus tag pairs all through. So these are the information that is retained after all the preparation for one review text. A lot of the words are stripped away because they normally don't add value to it. One reason that they don't add value, not simply because they are stop words, but just because they are stop words, they appear in every document. A word that appears in every document doesn't add value. That's basically the logic behind it. So we get rid of those, we save memory space, we save computational space, and we can focus on those unique words, words that are unique to specific documents. That's how you can see the relationships more better. When you put them together, all the steps is as simple as this. You create a custom filter. Keep in mind that in the filter, I use Lambda function all through, other than the last, because what happens is by using these functions, simple preprocess and lemmatize, what you get is a collectible. It's sort of like a list of words that cannot be directly fed into the next function. That's why I had to do space.glue, space.join. Every time I have to do the space.join to return a single string for each row. It cannot be a collectible. And also, the reason I need to use Lambda function is because by using, there's no single callable function that can do all of these. In all of these operations, you have to use a function, you have to use several functions. You have to use .join function, you have to use that main function that is doing the job. And you also have to specify arguments that are different from the default arguments. So all of these becomes the condition where you need to use a Lambda function to customize a specific callable function with specific arguments, but still it's not complicated. It's not too complicated. You can still write the whole, write the line of code that includes all the operations you need to do with all those arguments in one line. So that's why it's hard to put these two Lambda functions together, even if you might be able to. The line will become too long. It becomes, cumbersome to read. It doesn't help with even with your own development. So better keep them separate. Keep every line manageable, but comprehensive enough to save some lines. In the end, after strip numeric, I still get a list of tokens for every review. So I need to glue it. For this string, after pre-processed string, I get a collectible. I need to use space that join. It becomes a string again. So after these, this is simply doing it on one string. How do I implement this function on every call, on every element of the text column? This is to check that both the pipeline produce the same result as the stepwise. How do I apply this method on every cell of the column? I have to use that something I just talked about. Need to use apply function to apply whatever is a callable function to every element of the column. And inside this apply function, you use a Lambda function because you cannot simply use pre-processed string with the default argument. You have to supply with a custom filter. And by the end, you still have to glue things together. So it's too complicated for a single function. Then you need to use Lambda function. But the code is very simple, elegant after you have developed the custom filter earlier. I will not run this. I have run it before. It will take 2 minutes, so it's too long to wait for it. In the end, I will print 3 randomly selected text from the large data set, and here is the result. Obviously the original reviews are much longer. These are what remains, as will be treated as word features in the topic models. So that's it for today. Any questions? Well, we will open up for questions, and let's call it a day. Enjoy your night, I think. Feel free to leave, but stay for questions. Any questions?
Question, Professor.
Yeah.
Is there a time when see how we did that with words, if we're going to do that with phrases? Because you might have something that says it's like something was good, but then if you say not good, it means the opposite.
Yeah, very good question. Whether or not that's called 2-gram. So that's exactly what 2-gram does. It extracts word sequence to a certain length. Whether or not that will add value depends on how prevalent those cases are in the text that you're analyzing. If only a few people write like that, then it probably doesn't add too much value. Plus, it's a much more complicated algorithm to deal with word sequences, you know, because you have more constraints to deal with.
You mean you have to define more things?
2 grams, let's see, 2 grams will increase the feature space, I think. So let's say you have not and good, right? Not will probably get stripped away because it's a stop word, or even if it's not. So not and good with 1 gram, it's 2 feature, it's 2 word. But with 2 gram, you have not good as one possibility. Not, maybe somebody use not, it's another case. And good, not, and good. You have 4 features. So 2 features become 4 features. You have more variables. You have much more variations of the same text, but you have more variables. More variables means requires more resources to deal with. And a lot of cases you have word sequences that only happen once. You know, it's a challenge to deal with it. Do you retain it? Do you throw it away just because it's too infrequent? It's something that I'm not familiar with, so I can't say how valuable that will be. But you can certainly try and see the results.
Also, why would you put a maximum on the word text amount?
So that's the extreme length, right?
Yeah, 15 is what you did.
Right.
But
because
that?
rare words that is extremely long. Can you name a word that's over 15 characters? It will be hard. Even things like encyclopedia is not even 15. Encyclopedia is barely 15. It's almost
Right, so
not
that's what I
yet.
mean. Like, is it necessary to
It's helpful. Well, you will see a difference in, I guess, in the time that it takes to run an algorithm. Even if it's 1% difference in terms of data size, it means significant reduction in the matrix. In a matrix where those columns will probably have almost all 0 and only a few 1, because only a few text rows have that word. So those tend to be ranked very low in terms of information value. So typically, you know, choose a cutoff point is a common practice. You can certainly include everything and try, but you know what I talk about is mostly common practices.
All right.
Yeah.
Thanks.
Yeah, but if you're dealing with very technical contents, like legal documents, you may want to rethink about the length, or medical, medical materials. So those very specialized domain knowledge, domain fields will have special words that are very long, and those are compound words. It doesn't mean that it's so complex. It's simply putting things together into the same word. In that case, you want to retain more specialized words.
Great, thank you.
Yeah, sure. Any other questions? I guess we'll call it a night. See you.